Hello, everyone. The unit for these next 2 weeks is going to be ionic bonding. Ionic bonding is something we started to cover right before the closure. As a result, the beginning of this material is stuff we've already discussed and gone over, but I'm going to go through it anyway at a quicker pace, just for the sake of us all being on the same page. So today we're going to go through valence electrons in the octet rule, as well as ions in general, cations and anions, and what ionic bonding is in general, and the three types of bonding that there are. We're just going to talk about bonding in general. And then after that, the two sections you're going to be working on is the valence electron section and the anions and cations section on the worksheet. Okay, these questions should be familiar to you. You've probably already done them, but again, like I said, I'm starting with the beginning just for the sake of us all being on the same page. So if you remember how to do these sections, then it should be, an easy day for you in terms of, just getting through the work. But I'm starting from the beginning, even though you already done it, just for the sake of us all being on the same page. So let's get started. If you remember, the octet rule tells you how many valence electrons elements wants in their outer shell. The OCT prefix oct means 8, okay? So remember that elements want 8 valence electrons in their outer shell, okay? That's why it's called the octet rule, okay? Valence electrons is just the electrons on the outermost shell. If you forgot what that is in general, this little section here goes through it. How do you know how many valence electrons an element has? All you got to do is look at the group number. Remember, this only applies to the A groups. The B groups are your transition metals. Everything with a B in it is a transition metal. Okay, these are your transition metals. So just look at the group number. Group 1 has 1, group 5 would have 5, group 7 would have 7, so on and so forth. If the A and B groups thing confuses you, just think about it like this. Ignore the middle columns. The ones that are taller than the transition metals. See how these are taller than the middle section? You can look at just the group number in general, but if it's a teen, like 13, 14, 15, if it's in the teens, just drop the 1 in front and you can still use that too. So you could say this is group 5A, or you can say this is group 15. Just drop the 1 and it's still 5. Drop the 1 here and this is still 7. It's 18, drop the 1 and it's still 8. So you can still just use the group number in general. Just remember to drop the 1. So those are the two ways you can look at it. But the group number either way is going to tell you the number of valence electrons that something has. So I'm going to go through 2 of these just so you can, for the sake of practice. So how many valence electrons does potassium have? Potassium is K. K, group 1 or 1A. So that'd be 1 valence electron. Aluminum. Aluminum is Al. It is here. This will be group 13. Drop the 1, that's 3 valence electrons, or 3A. The 3 tells you it's 3 valence electrons. So this would be C, okay? So again, just look at the group number, and it tells you how many valence electrons that element has. Now we're in the ions. All an ion is a charged particle, okay? That's all ions are. It could be positive or it could be negative. But an ion in general is just a charged particle. Okay. Then you get specifics. You have cations and you have anions. The cations have a positive charge, and the anions are your negative charge. They're both ions. Ions are just charged particles. The positive ones, or the cations, are always going to be your metals. Okay. And the anions, the negative ones, are going to be your non-metals, okay, or your gases for the most part. So when you form a cation, remember positive charges, cations want to lose electrons, okay? How do you know if you're going to lose electrons or gain electrons? If you have less than 4 valence electrons, you're going to lose electrons. If you have 5 or more, you're going to gain electrons. So it's about getting to the noble gas column as quickly as possible. Again, for these elements, the cations, it's easier to lose electrons to get to a noble gas than it is to gain. For these on the right, it's easier to gain electrons to get to the noble gases than to lose. Okay. So if you have less than 4, you're going to lose electrons. If you have greater than 4, you're going to gain electrons. If you're exactly at 4, you could be either or. Okay. So if you remember the electron configuration, the boxes, this is giving you an example of a cation. In this case, we're looking at sodium. Sodium is Na. Na is in group 1, so it has 1 valence electron. So if it loses 1 electron, this box, the 3s, is going to now become empty, okay? Because now it lost 1, now it's like neon. Neon is here, is in group 8, okay? 8A, group 18. And neon would be right here in the second period, okay? So that the ending would be 2p6. You drop that electron, it's now empty, and now you finish at 2p6, okay? And now you're just like neon. Cation loses an electron, box becomes empty. And remember that cations get smaller, okay? The reason cations get smaller is because you're losing an electron. You lose an electron, you lose the shielding. You lose the shielding, you get a stronger pull and it shrinks, okay? So these are just cations in general, and the rest is just going through, the number of valence electrons tells you how many you're going to lose. So 1A is going to lose 1, 2A is going to lose 2, 3A would lose 3. Here's another example. Now we're doing anions. We're looking at chlorine. Chlorine is a halogen. The halogens are in group 7A, so they have 7 valence electrons. They only need 1 more to get to 8, so all your halogens are -1. So in this case, if it's -1, it's gaining 1 electron. Look at the last box. Okay, so if we're gaining an electron, we're going to gain an arrow. What happens is this last box gets filled, and you now have 2 in there. Now it's paired. Now we have a full energy level. We have our 8 valence electrons in level 3, and we end up like argon. Okay, so we went from here, chlorine, we got an extra electron, and we ended up right here. The noble gas that is there would be argon. Okay, that's the noble gas that's in that box. And anions, they get bigger. The reason they get bigger is because we're gaining an electron. You gain an electron, you increase shielding, and you increase shielding, you're increasing the repulsion, and you get a larger ion, okay? So anions get bigger, cations get smaller. Remember that. And this is just going through the rest of the groups, okay? So if you're in 5A, you need 3 more, so you become -3. 6, you need 2 more, so it's -2. 7, you need 1 more, so you have -1, okay? A quick little review. Metals tend to blank, non-metals tend to blank. Remember that cations tend to be your metals. Okay, cations are the positive ones, and the positive ones are in groups 1, 2, and 3, and those are further to the left, and the majority of the left side is your metals. Okay, so metals tend to lose electrons. They want to be cations, and non-metals tend to gain. Okay, so this is D, lose and gain. Same question, basically, just worded a little differently. Now we're looking at anions and cations. So anions, anions tend to be nonmetals, and cations tend to be metals. Okay, so this would be D again. So anions are nonmetals, and cations are metals. And metals lose electrons from cations. That is true. This is just a quick little review, so on and so forth. So I'm gonna go through this. We've already done this. Let's do one example of one of these. Phosphorus forms an ion with a charge of. So now you have to look at the table. Well, let me go, matter of fact, let me just go to ptable.com. Phosphorus is here. P, that's group 15. Drop the 1. We have 5 valence electrons. 5 is greater than 4, so you know this is going to become an anion. How many steps do we need to take in order to get the noble gas? 1, 2, 3. So we need 3 electrons, and we're gaining, so we're going to become minus. So phosphorus would be -3. Okay, phosphorus would be -3, so the answer is D. Aluminum forms an ion with a charge of what? Aluminum is in group 13. Drop the 1. 3 valence electrons. 3 is less than 4, so we're going to lose those electrons. If you're losing electrons, you become positive. So the charge is going to be plus 3. So that'd be C. Okay. Now let's get to the last section. Ionic bonding. So what is ionic bonding? Ionic bonding is a bond that stems from positive and negative attraction. Okay. So how you form an ionic bond is first you have to form ions. It's called an ionic bond because what's bonding are ions. Cations are going to bond with anions. That's what's happening. So your three main bond types. You have ionic, you have covalent, you have metallic. I just had you go through covalent the last 2 weeks. Now we're going to go through ionic this week. Okay, covalent was sharing of electrons. Ionic is basically the stealing of electrons. So the anion takes the electron from the cation. Okay, that's how you get the charges. And then the positive and the negative, they are attracted to each other, and so you form a bond. Okay, so ionic bonding is based solely on electronegativity. Okay, the stronger the attraction, the more likely you are to form an ionic bond. And more specifically, for you to form an ionic bond, you need to have an electronegativity difference of greater than 1.7. If you remember from covalent bonding, had to be between 0.4 and 1.7 for it to be considered a polar covalent. And if it was less than 0.4, you had a non-polar covalent. But if it's greater than 1.7, you have ionic. Okay, so all of these bonding types that we're going to be looking at, they're all going to have a difference greater than 1.7. Basically, ionic bonding is always between a metal and a non-metal. Okay, so if you see metal and a non-metal, automatically you know it's ionic bonding. So here we have two different elements. This one has 3 valence electrons, so this would be not 3. This one has 1 valence electron. It has 1 valence electron, so this would be group 1. So this would be one of the alkali metals. So whatever it is, it's going to be one of these. And I see that it has 3 electrons. It has 3 electrons total, so I'm guessing it's lithium. So this right here is lithium. And this one has 7 valence electrons. It has 9 total. That is fluorine. Okay, so we're looking at lithium and fluorine, lithium and fluoride. Li1, it's going to lose that 1 electron and it's going to give it to the fluorine. Fluorine is then going to have 10 and it's going to be like neon. Okay, it's going to become that noble gas. So now you have something that's 2 and something that's 10. So this became like helium now. Lithium lost that electron, now it's like helium. Fluorine gained an electron, now it's like neon. But now this is positively charged and this is negatively charged. So and opposites attract. So now they're attracted to each other and they form a bond. And now you have lithium fluoride. Okay, we'll get into naming another day, but this is what this would be. This is lithium fluoride. Lithium and fluorine combined, you get lithium fluoride. The bond between them comes solely from electrostatic attraction. Okay, remember electrostatic just means the positive and negative charges. So once the electron gets transferred, you get the positive and negative charge, opposites attract, and you form a bond. Okay. Once you form the bond, the charges cancel and they're neutral. Okay, so even though individually the lithium is positive, the fluorine is negative, once they come together, the charges cancel and the compound is neutral. Lithium by itself is positive, fluorine by itself is negative, but when you bring them together, the charges cancel. So remember that the compounds themselves are neutral, okay? Unless you see the symbol positive or negative with it, okay? But the compounds after they form the bonds are neutral, and the bonds are called ionic bonds, okay? So that's where that stems from. Here they're giving you the example with the Lewis structure. Chlorine, you would draw 7 dots because it has 7 valence electrons. If you remember from covalent bonding, we did these dots a lot, okay? So chlorine would get 7 dots because it has 7 valence electrons. Sodium will get 1 dot because it only has 1. The chlorine takes it from the sodium. And now the sodium is positive and the chlorine is negative. And here's a table giving you the breakdown for the electronegativity numbers, okay? So remember, you need to have a difference greater than 1.7 in order for you to have an ionic bond. So question, which pair of atoms would form an ionic bond? Lithium and neon, potassium and bromine, potassium and CS, and sulfur and chlorine. So remember that if you see metal and non-metal, right away you know it's ionic. It is an A because one of them is neon. Neon is a noble gas, and we know noble gases do not react. So it's not A. Potassium, K, is a metal, and bromine is a non-metal. So I know right away these are going to be ionic, but let's look at the numbers just to be safe. Br is 2.8, potassium is 0.8. You subtract them, you get 2. 2 is greater than 1.7, so you know it's ionic. Let's look at the rest of them just to be safe. Okay, so this is no reaction. And I'm going to abbreviate reaction with RXN. So this is no reaction. This has a difference of 2. 2.0 would be ionic. Potassium and CS, which I believe is cesium. I may have that mistaken, but potassium is 0.8. And CS, where are you? If I'm not mistaken, you should be somewhere around here. CS, right there. So you have a metal and a metal, okay? So this is 0.8 minus 0.7, so that's a difference of 0.1. So this would be 0.1. 0.1 is most definitely not greater than 1.7, so that would not be ionic. And then you have sulfur and chlorine. Sulfur is 2.5 and chlorine would be 3. So the difference between them would be 0.5. That would not be ionic, that would be covalent. Okay, so the answer here is B. That same idea, just look at the numbers. So I'm going to skip that one. Same thing, look at the numbers. So I'll skip this one. Which of the following compounds would you expect to be ionic? To answer this question, you just need to look for a metal and a non-metal. Hydrogen and oxygen, they're both non-metals, so it's not this one. Carbon and oxygen, these are both non-metals, so it's not B. Cr and chlorine, so that's a metal and that's a non-metal. So this would be ionic. And then D, S, and O, sulfur and oxygen. Both of these are non-metals, so I would not expect it to be ionic. So the answer to this one would be C. And if you go up to the table, SR is over here. Cl over here. 3 minus 1 is 2. 2 is greater than 1.7, so that would be an ionic bond. So with questions like this, you just look at do we have a metal and a non-metal? If you do, it's ionic. And that's the last question, and that stops here. Okay, so that's it for the slides. Let's go through some practice problems real quick, just so you can have the idea. Remember, for this week, we're just doing valence electrons and anions and cations. These are the 2 sections. The valence electron section is short, and that's why I added the second one. And again, you may have seen this work already. You have seen this work. If you remember it, it'll be easy for you. But you guys have done this before already. But again, for the sake of just being on the same page, we're going to go through it again. So I'm going to do one example from each classwork and homework section. So let's do phosphorus for this one. How many valence electrons does phosphorus have? Remember the valence electrons, you just have to look at the group number. Phosphorus P, it's in group 15. Drop the 1 and you get 5 valence electrons. Okay, so phosphorus would have 5. Just got to look at the group number. Let's do one from the homework section. Tellurium. Okay, how many valence electrons does tellurium have? Let's find tellurium. Tellurium would be Te right here. Te is in group 16. Drop the 1. This is 6 valence electrons. So it would be 6. For the rest of them, just look at the group number. The group number will tell you how many valence electrons you have. That's how you do this section. Anions and cations. Predict if the following elements will produce anions, cations, or neither. Okay, or neither. So let me just write these rules down real quick. So, greater than 3 or greater than 4. Remember this, so this symbol means greater than 4 equals anion. Okay. This is just for your reference. Less than 4 is your cation. Okay. So if we have greater than 4, you have an anion. If you have less than 4, you have a cation. If you're exactly at 4, you could be either one. So to answer this question, what you need to figure out is how many valence electrons they have. Nitrogen. Nitrogen is in what group? It's in group 15. So it would have 5 valence electrons. 5 is greater than 4. Because 5 is greater than 4, this would be an anion. Okay, so I'm just going to put A for anion. Potassium. I'm just going to jump around. I'm going to give you an example of each, of an anion, a cation, and neither. Potassium is in what group? Potassium is K. K is in group 1, 1 valence electron. 1 is less than 4, so this would be a cation. C for cation. Argon. Argon is in what group? Argon is in group 8. Drop the 1, we have 8 valence electrons. And the elements that have 8 valence electrons, remember these are your noble gases. Noble gases are already happy. So this one is not going to be an anion or a cation. This one is going to be neither, okay? This is not going to get charged. It's not going to lose an electron. It's not going to gain an electron. It's just going to be happy just the way it is. Okay, and these open-ended questions, based on the electronegativity, what is the difference between elements that tend to form anions and the elements that tend to form cations? I will leave that up to you to decide. Just to answer this question, you got to know what the elements that are cations tend to be what, the elements that are anions tend to be what, and how, like, what is the difference between those elements. One is one category, the other one is another category. Just remember what they are and you can answer that question. And then from what you know about the periodic trends, remember the trends include atomic radius, metallic character, electronegativity, and ionization energy. Those are the trends we talked about. Based on what you know about the trends, will transition metals form anions or cations? So based on what you know, which one are they likely to be? So cations tend to be what? With that alone, you should be able to answer the question. So that's it for day 1. Okay. So if you have any questions, again, always ask. You can work together, but this material should be familiar. We've worked on it before, but yeah, that covers everything for day 1. These next couple of days, probably day 1 and day 2, I believe I'm gonna go through it a little quickly, just because again you've seen it before. But after day 2, everything else should be new. And then we'll start slowing down and going more in depth. All right. But thank you for your patience. I know this has not been the easiest transition, but hopefully you guys are getting through it fine. Thank you, and enjoy the rest of your day.